Design a fire filter, low pass filter using rectangular window with passband gain of unity, cutoff frequency of 200 Hz, sampling frequency 1 kHz. Assume length of the impulse response as a 7. So first we write what is given. FC is given, cutoff FC it is 200 Hz. So sampling frequency also, that is Fs is equal to 1 kHz, that is 1000 Hz. Length is also given, it is M is equal to 7. Now step 1. Step 1 is from given specification, we write here from given specification desired response of ideal low pass filter, can be expressed as h d of omega is equal to, it is 1 for 0 is f is in between 0 and 200 Hz, and it is 0 if f is greater than 200 Hz. This is equation 1. Now the normalized cutoff frequency omega c is, it is equal to 2 pi fc by fs. So it is 2 pi into 200 divided by 1000. So it is equal to 1.257 radian per second. Thus the desired frequency response, can be expressed in terms of omega c as h d of omega is equal to, it is 1 and 0, omega is in between 0 to 1.257 and it is in between, this is equation 2. Now next is step 2. Step 2 is filter coefficients are given by hd of n is equal to 1 by 2 pi minus omega c to plus omega c hd of omega e raised to j omega n omega. So it is 1 by 2 pi minus 1.257 to 1.257 1 into e raised to j omega n. So that is equal to 1 by 2 pi, its integration. Now integration value is minus 1.257 to 1.257. So we write these integration values here. The equation is hd of n is equal to by 2 pi e raised to j 1.257 n minus j 1.257 n by j n. Now we have to use here trigonometric identity. So we write using trigonometric identity. identity. Sin theta is equal to e raised to j theta minus e raised to minus j theta divided by 2j. So we get h d of n is equal to sine of 1.257 n by pi n, where n is not equal to 0. This is equation 3. Now for n is equal to 0, we get h d of 0 is equal to 1 by 2 pi integration minus 1.257 to 0.257 1 into e raised to 0 d omega. So we replace here the values. It is 1.257 minus of minus 1.7. So h d of 0 is equal to 0.4. Now step 3. For rectangular window, h of n is equal to ht of n into wr of n, and wr of n is equal to, it is 1 or 0 for n is equal to 0 to m minus 1, that is 0 to 6, and 0 value is for other values other than 0 to 6. Therefore hn is equal to hd of n for n is equal to 0 to 6. Now next is the values of hd of n. So here is a table, value of n, value of hd of n, that is equal to h of n. So it is 0, 1, 2, 3, 4, 5 and 6. Next is, now here also we directly substitute the values and we find the final answer. So we have equation for the hd of n. We replace here n is equal to 0, 1, 2, 3, 4, 5, 6. So we get this value of hd of n, which is value of h of n. So here it is 0.4, 0.302, next is 0.093 minus 0.062, 0.075, 1.15 into 10 raised to minus 4, and it is 0.05. So this is the table which shows the very different value of hd of n, that is h of n, for the different values of n. The desired frequency response of low pass filter is hd of e raised to j omega is 1 and it is 0 for these different values of omega. Determine hd of n, also determine hn. So first is calculation of hd of n. Calculation of hd of n. We have equation for this. The problem was asked in exam for the 8 marks. So we have h d of n is equal to 1 by 2 pi integration minus omega c to plus omega c h d of e raised to j omega n d omega. So we can write here h d of n is equal to 1 by 2 pi, it is minus pi by 2 to pi by 2, 1 into e raised to j omega n omega. This is equation 1. Therefore hd of n is equal to 1 by 2 pi, it is e raised to j omega n by j n integration values. So we substitute these integration values here. it is e raised to j pi by 2 n minus e raised to minus j pi by 2 n. So it is 1 by pi n, it is jn. Okay, here is jn. So it is 1 by 2 e raised to j pi by 2 n minus e raised to minus j pi by 2 n divided by 2g. So therefore hd of n is equal to 1 by pi n sine of pi by 2 n for n not equal to 0. Now to obtain the values of n is equal to 0, put n equal to 0 in equation 1. Put n is equal to 0 in equation 1. Therefore hd of n is equal to 1 by 2 pi integration minus pi by 2 to plus pi by 2 1 into e raised to 0 d omega. So it is 1 by 2 pi, it is pi by 2 integration values plus pi by 2, so it is 1 by 2. Now hd of n is equal to 1 by 2 for n is equal to 0. Therefore hd of n is equal to 1 by pi n sine pi by 2 n for n not equal to 0. This is equation 3. This is equation 2. Now next step is calculation of Hn. Next step is calculation of Hn. Calculation of h of n. Now we have h of n is equal to hd of n into omega n, where this omega b of n is Bartlett window function, and it is given by equation it is equal to 1 minus 2 for n less than equal to m minus 1. Now here m is equal to how much? It is 7. So next is a table for the calculation of Hn. So it is value of n, next is h d of n, w b of n, and next is h of n. So we have the equations for hd of n, wb of n, and hn is the multiplication of both these two. Now values of n is 0, 1, 2, 3, 4, 5, 6, because n is m minus 1, that is up to 6 only. So it is here I directly write the answers. It is 1 by 2, 0.3180 minus 0.106. Just substitute these 0, 1, 2, 3, 4, 5, 6 values in the equation of hd of n and wb of n. 0.0637 and it is 0. Next is 1, 0.67, 0.33, 0, minus 0.33, 0.67, and it is minus 1. Next is half, 0.1, sorry, 212, it is 0, 0 and 0. Next is minus 0.042 and it is 0. So this table shows the calculation of Hn. Next problem, an FIR filter is to be designed to meet the following specification: passband 150 to 250 Hz, transition width 50 Hz, passband ripple 0.1 dB, stopband attenuation 60 dB, sampling frequency 1 kHz. Determine the order of the filter and the select appropriate window function. The problem was asked for the 6 marks in exam. So solution for this is step 1 is calculation of delta. So delta is equal to, we have the equation for this as 10 raised to 0.05 minus 1 divided by plus 1, and delta S is equal to 10 raised to minus 0.05 S. So these two are the equations. Now, where AP is equal to 0.1 dB and AS is equal to 60 dB, therefore delta P is equal to, so it is 5.77 into 10 raised to minus 3, and it is equal to 0.001. We replace the values of AP in the above equation and we get the values of delta P and the delta S. So we can find value of this. It is 5.77 into 10 raised to minus 3, and its value is, it is equal to 5.77 into 10 raised to minus 3. Next step is calculation. Step 2, calculation of attenuation A. It is A is equal to minus 20 log to the base 10 of delta dB. Therefore A is equal to minus 20 to the log of 5.77 into 10 raised to minus 3. Therefore A is equal to 44.78 dB. Now next is step 3. So filter length is given by M is equal to A minus 8 divided by 2.285 delta omega plus 1. Here what is delta omega? It is equal to omega S minus omega P, that is 2 pi Fs minus 2 pi Fp. What is Fs? It is equal to stop band. It is equal to stop band H frequency, that is 250 Hertz. So it is equal to 250 divided by Fs. So that is equal to 250 divided by 1000, and Fp is equal to pass band H frequency, that is equal to 150 Hertz. So it is equal to 150 by Fs, that is equal to 150 divided by 1000. Now we replace this value in above equation. It is 2 pi into 250 divided by 1000 minus 2 pi into, it is 2 pi into 250 divided by 1000. So the value of this is 0.628. Now we have the value of delta omega. Now we can find the value of M. So M is equal to 44.78, which is the value of A, minus 8 divided by 2.285 into delta omega value is 0.628 plus 1. Therefore M is equal to 26.6 which is nearly equal to 27. Now next part is, here second part of the problem, we selecting case window function, and it is given by w of n is equal to I0 of, this is the equation for this window, divided by I0 of beta, and this is for n is in between 0 and m. Now here alpha is equal to m by 2 and I0 of x is equal to 1 plus 0.25 x square by 1 factorial plus 0.25 x square of square by 2 factorial square plus dot dot dot, and beta is equal to 0.582 a minus 21 raised to 0.4 plus 0.07886 a minus 21. Thank you.